Question 8. Otto knows that his truck requires 27.5 litres of fuel to drive 110 kilometres, and he wants to drive from London to Edinburgh, and it's a distance of 405 kilometres. So how much fuel will he need? That is the big question that we need to answer. So we could show this on a dual number line, and we know that 110 kilometres is uses 27.5 litres of fuel, and he wants to drive 405 kilometres. So if we put 405 kilometres here, so we need to know how many times 110 kilometres goes into 405. So you could do 405 divided by 110, and that would equal approximately 3.68. So it goes in 3.68 times. So that goes in 3.68 times. So we would need to do the same to the amount of fuel, because if you're going 3.68 times the distance, we'd use 3.68 times the fuel, and that's approximately. So if we multiply that by 27.5, that's roughly going to give you about 101.25, but let's call it 101 litres if we just round it to the nearest whole number. So he would need 101 litres. So what we did there is we did the distance, 405, divided by the rate, the 110, or the 110 kilometres. We multiplied that by the 27.5, and that gave us our 101 litres is what's needed. In this question, Caleb wants to paint his house. He checks instructions in the paint tin and finds that 1 tin of paint, so 1 tin of paint will cover 5 square metres. The total wall area Caleb needs to paint is 40 square metres. How many tins of paint will he need to buy? So we could use a dual number line for this, and we know that one tin covers 5 square metres, and we know that he wants to cover 40 square metres. So we know that 5 goes into 48 times. So then we would need to use 8 times the amount of paint. So that's 8 tins of paint are needed. Jack rides his bike 12 kilometres for 2 hours. How far has he travelled? So we know that he travels at 12 kilometres per hour. So he does 12 kilometres in 1 hour. And if he travels for 2 hours, that's double that. So it's double the time, so it will double the distance travelled, so that would be 24 kilometres that he would travel in 2 hours. In this scenario here, Hamid walks 6 kilometres per hour for 45 minutes. How far has he walked? So again, we know for 1 hour, he does 6 kilometres, so that's in 1 hour, 6 kilometres per hour. He's walking less than an hour, so he's going to cover less than 6 kilometres. So we want to find for 45 minutes, which is 3/4 of an hour, or point. So 3/4 of an hour is 45 minutes. And I'll just put under there 45 minutes as well. So few of the ways we could do it. We could do, well, we know that half an hour, which is 30 minutes, will be half the distance, so that's 3 kilometres. And then if we halve that again, that would give us 15 minutes, or 1/4 of an hour will give us half of 3, which is 1.5 kilometres. So we know that 3/4 of an hour, or 45 minutes, is made up of 30 minutes and 15 minutes. So it would be 1.5 plus 3 kilometres. So that would be 4.5 kilometres. Now, another way that we could do this is we know that speed is equal to distance over time. Now, the speed we know, he's walking at 6 kilometers per hour. So 6 is equal to, and the distance we don't know. So the distance is unknown, and the time is 3/4 of an hour, or 0.75 hours. So the way that we could work this out, this is more of an equation method. We want to get distance on its own. So we've got distance divided by 0.75 hours. So we do the opposite of divide by, we multiply by 0.75. And what we do on the right-hand side of the equation, we need to do on the left-hand side of the equation. So we times that by 0.75. And we'd end up with distance on its own on one side. So distance would be equal to, because these would cancel out, distance is equal to 6 times by 0.75, which would give us 4.5 kilometers. That's the distance that he would travel. So with 12, Troy drives his car at a speed of 110 kilometers per hour for 1 hour and 15 minutes. How far has he traveled? So again, we're wanting to know, it's a distance problem. We want to know the distance that he's traveled. And we could use our dual number line again. So in 1 hour, which is 60 minutes, he's travelled 110 kilometres, because that's 110 kilometres per hour. So he's travelled for 1 hour and 15 minutes. So I'm going to put this here, 1 hour and 15 minutes, 1 hour and 15 minutes, which is the same as 60 minutes plus 15, so 75 minutes. Okay. We know it's going to be more than 110 kilometres because he's going for longer than 60 minutes. We could, if we know that 1 hour, which is 60 minutes, is 110 kilometres, well then we know that half of that is 30 minutes, which is half an hour. So that would be half the distance, 55 kilometres. And then if we know that 30 minutes is 55 kilometres, half of that is 15 minutes, which is 1/4 of an hour. So that would be half the distance. So that would be half of 55 kilometres, which would be 27.5 kilometres, would be 15 minutes. So we would just need to add that on, because remember, 75 minutes is made up of 60 minutes plus 15 minutes. So we would just need to add on 27.5 onto the 110. And if we add that on, that would be 137.5 kilometers in an hour and 15 minutes. So again, using the speed formula, that method, we know speed is equal to distance divided by time, which is in hours. So our speed we're given as 110 kilometers per hour is equal to distance, which is the unknown. That's what we want to find out. So distance divided by our time in hours, which is an hour and 15 minutes. Now we need to write an hour and 15 minutes. We need to write that just in hours. So 15 minutes is 1/4 of an hour. So it's 0.25 hours. So an hour and 15 minutes is 1.25. That's an hour and 1/4, an hour and 15 minutes. So we want to get distance on its own. So we've got distance divided by 1.25. So we times that by 1.25 to cancel that out. And we need to do the same on the other side. Times by 1.25. And we get distance is equal to 1.25 times 110, which gives us 137.5 kilometers. So that is the distance. And question 13, Tom travels 40 kilometers by train in 35 minutes. What speed is he traveling at? So this is this is a question where the speed is the unknown. So we know the distance travelled and we know the time. So we know that in 35 minutes, he travels 40 kilometres. So when we're giving the speed, we want to know per hour. So what we're wanting to find out is we want to know for 60 minutes, which is 1 hour. Okay, we want to know what distance is travelled in that time, and that will give us a speed. So one of the ways that we could do it is, if we know that 35 minutes is 40 kilometres, we could then go, I know that 5 minutes, if I divide 35 by 7, that gives me 5 minutes. Then I would need to do the same up here as well with the distance, divide by 7. So that gives me 40 divided by 7, which gives me approximately 5.71 kilometres. So if I know in 5 minutes you can travel 5.71 kilometres, then I know in 60 there are 12 lots of 5 minutes. So I would need to multiply this by 12 as well. And that would approximately give me about, to one decimal place, roughly about 68.6 kilometres. So the speed would be 68.6 kilometres per hour. So for every hour, that's how far you travel. Using the speed formula, so when we should get the same answer, speed equals distance over time. So our speed is the unknown, so I'm going to write speed, it's unknown, equals distance. So it travels 40 kilometres. So I'm going to put distance is 40 kilometres over the time. It's 35 minutes, but we need to put that in hours. So 35 minutes, to write that into hours, we do 35 out of 60 minutes. So if we do 35 divided by 60, that gives us approximately 0.58. So it goes 0.583 recurring, so let's just put 0.58. So it's 0.58 hours. That's what 35 minutes is, which makes sense because 30 minutes is half an hour, that's 0.5. This is slightly more than that, it's 0.58. So if we divide that by 0.58, then we get 40 divided by 0.58, and it gives us slightly different from what we did before because I've been rounding, but again, it's approximately 68.6 kilometres, very roughly, per hour. So we've done some rounding, so it'll be slightly off.